So you are welcome back. So we are still under sort, but today we are going to look at rationalization of sort. So under rationalization of sort, we are going to look at rules of rationalization. Then after that, we are going to we are going to move to simplification of sort using rationalization method of solving. Then under rules of rationalization, what do I mean by rationalization? Is to make the denominator or to make the sort or to make the denominator of the sort a non-sort figure or to make it a rational number, making the denominator to be a rational number. That is the meaning of rationalization. And to do that, we have some rules to follow. So the first one will be A all over root B. So to rationalize this or to simplify this, we are going to rationalize because having sort as the denominator is improper under sort. So to do that, we rationalize as A over root B multiplied by root B all over root B. So given as A root B, we get A root B by multiplying numerators together. Then all over root B multiplied by root B is the same thing as B. So we got this from square root of B squared. Square, we cancel the roots. That's why we are left with ordinary B. So root B multiplied by root B give us B. So invariably, whenever you are multiplying the same sort together, like root 2 multiplied by root 2, the answer will be 2. That is under rules of rationalization. So the next one is 1 all over root A. So 1 over root A is simply as 1 over root A multiplied by root A all over root A. So we give rise to root A all over A. So 1 over root A, by rationalizing this, we have 1 over root A multiplied by root A over A, which is 1 times root A. Root A multiplied by root A, we have ordinary A. Then the next one is A all over root A B plus root C. So in this form, we have combined sort there, which is root B plus root C. So to simplify this, we are going to rationalize. To rationalize, we are going to multiply both numerator and denominator by conjugate of denominator. And what will be the conjugate of denominator on this? It will be root B minus root C. So we are going to use root B minus root C to multiply both numerator and denominator. So we have A all over root B plus root C multiplied by root B minus root C all over root B minus root C. So we have A into root B minus root C all over using the rule of sort and its conjugate. So it's going to be B squared minus C squared as the simplification. So let's stop there. We are going to see the remaining solution under simplification. So let's move to simplification of sort now. Simplification of sort under rationalization. So the first example is simplify 3 all over root 8. So this type of question is improper under sort because we have sort as our denominator. So to do that, to simplify this, we are going to rationalize, but we can as well simplify before we rationalize. So we have 3 all over root 8, which is 3 all over square root of 8 can be written as square root of 4 times 2, which is the same thing as 3 all over 2 from the square root of 4, then root 2. So we have 3 all over 2 root 2. We still have sort as the denominator, so we can now rationalize. So we have 2 ways of rationalizing this type of question. So you can rationalize as 3 all over 2 root 2 equal to 3 over 2 root 2 multiplied by, you can pick only root 2 and rationalize it, or you can pick the 2 at the same time. We are still going to arrive at the same answer. So then you pick only root 2 first. So it's going to be root 2 all over root 2. So simplifying this, we have 3 root 2, 3 root 2 by multiplying numerator with numerator all over 2 into root 2 multiplied by root 2 is ordinary 2. So which is the same thing as 3 root 2 all over 4. So this is one of the answer. This is the solution to 3 all over root 8. Or you can as well, you can use the second method, which is 3 all over 2 root 2, which is equal to, so you have to rationalize both numerator and denominator by all the denominator. So it's going to be 3 all over 2 root 2 multiplied by 2 root 2 all over 2 root 2. So which is equal to, so 3 multiplied by 2 give us 6 root 2 all over 2 multiplied by 2, that is 4, and 2 root 2 multiplied by root 2, that is ordinary 2. So we have 6 root 2 all over 8. So here we have common factor, you can reduce it. So 2 and 6, 3, 2 and 8, 4. So that's why we have 3 root 2 all over 4. So you can see we have the same answer using ordinary root 2 or 2 root 2 to rationalize. So thank you. So the second question says express 8 minus 3 root 6 all over 2 root 3 plus 3 root 2 in the form m root 3 plus m root 2, where m and n are rational numbers. So this is y equation. So we are going to simplify it and express it in the form m root 3 plus n root 2. So to do that, if you look at the equation given, it's a combined surd. We have combined surd at the denominator. So we are going to find the conjugate of the denominator of the surd in the given question. So the conjugate of the surd there is 2 root 3 minus 3 root 2. So we now use the conjugate to multiply both numerator and denominator. And to do that, we have 8 minus 3 root 6 all over 2 root 3 plus 3 root 2 multiplied by, then the conjugate of the denominator is 2 root 3 minus 3 root 2 all over 2 root 3 minus 3 root 2. But don't forget, you must equate this to what? M root 3 plus n root 2. So we are working towards that. So let's now simplify this. So by multiplying numerator with numerator, denominator with denominator. So we have 8 into bracket. Use 8 in the first numerator here to multiply all the numerator in the second numerator. So we have 8 into 2 root 3 minus 3 root 2. Then minus 3 root 6 multiplied by 2 root 3 minus 3 root 2. So that's all for numerator. Then all over the denominator. That is surd and its conjugate. So using the rule of surd and its conjugate, we are going to have 2 root 3 all squared. Then in plus minus here, we are going to have minus, that is 3 root 2 all squared, equals to m root 3 plus n root 2. So let's now open the bracket in the numerator. So we have 8 times 2, that is 16 root 3 minus 8 multiplied by 3, that is 24 root 2. Then we are done with the first bracket. Then the second bracket, 3 root 2 multiplied, that is 3 times 2. That is minus, we have minus here, minus times plus minus, 3 times 2, 6. Root 6 multiplied by root 3. That is square root of 18. Then minus times minus plus 3 multiplied by 3, that is 9. Root 6 multiplied by root 2, that is square root of 12, all over 2 squared, that is 4, into square root of 3 squared, that is ordinary 3, minus 3 squared 9, open bracket, square root of 2 squared, that is 2, so which is equal to m root 3 plus n root 2. So the next thing is to simplify further. So we have 16 root 3 minus 24 root 2, then minus 6, open bracket. In this 18 we have a perfect square. That is 9 square root of 9 times 2, then plus 9. So let me close the bracket there. So plus 9, open bracket, square root of 4 times 3. So close the bracket, all over 4 times 3, that's 12, minus 9 times 2, 18. So which is equal to n root 3 plus n root 2. So we have 16 root 3 minus 24 root 2. Then minus 6 root 9 times 2 plus 9 root 4 times 2. We have 16 root 3 minus 24 root 2. Then we have minus 6 into square root of 9 is 3. So we have 3 root 2. Then plus 9 into square root of 4, that is 2 root 3, all over 12 minus 18, that is minus 6. So which is equal to n root 3 plus n root 2. So after this, we are going to have 16 root 3 minus 24 root 2 minus 18 root 2 plus 18 root 3 all over minus 6 equal to n root 3 plus n root 2. So we now collect the like terms. So we have 16 root 3 plus 18 root 3. Because we are working towards this, so we have root 3 before root 2. So that's why root 3 came first. So we have minus 24 root 2, then minus 18 root 2, all over minus 6 equal to n root 3 plus n root 2. So 16 root 3 plus 18 root 3, that is 34 root 3, then minus 24 root 2 minus 18 root 2 gives rise to minus 42 root 2 all over minus 6, which is equal to n root 3 plus n root 2. So after this, we can now look for the common factor. I think 2 is common, so we are going to factor out 2 here. So we have 2 into 2 in 34, that's 17 root 3, minus 2 in 42, that is 21 root 2, all over minus is equal to n root 3 plus n root 2. So 2 here 1, 2 in 6, 3. So we now left with minus 1 over 3, open bracket 17 root 3 minus 21 root 2, which is equal to n root 3 plus n root 2. So with this, we can divide through, we can open the bracket by having it as minus 17 over 3 root 3. So minus times minus, that is plus, that is 21 over 3 root 2, which is equal to n root 3 plus n root 2. So if you look at this, 3 can still go in, can still goes in 21, so which is equal to minus 17 over 3 root 3 plus 3 and 3, 1, 3 and 21, 7. So that is 7 root 2, which is equal to n root 3 plus n root 2. So if you now compare the left hand side and the right hand side, so in this case, n is equivalent to 17 root 3 minus 17 root 3, while n is plus 7. So I think it's well explanatory. Please, I need you to go through this question one after the other, and if you have any difficulties, you can just send your comment up to the comment section. Thank you so much.